R4, factoring polynomials. So starting with number 18, it says to factor out the greatest common factor from each polynomial. So that's the only thing we're doing in these ones. We don't have to do anything beyond that. So negative 3z to the fifth w squared minus 18z cubed w to the fourth. So I want to take out the biggest thing that I can from each piece. So any idea what that would be for this one?
-3z to the third y to the second.
W.
W. That's fun.
Yes, negative 3z cubed w squared. And so then when you take that out of each piece, you are left with z squared in the first one, and then plus 6w squared. And that's all these ones want us to do, is just to take that out. So same instructions, 28, r to the fourth s squared plus 7r cubed s minus 35 r to the fourth s cubed. So what's the biggest thing that I can take out of all three of these?
28r to the fourth s squared. No, not 28. 7r to the 7r cubed s.
Yep. 7r cubed and then s. So that's the biggest thing out of each one. So then inside I'm left with 4rs plus 1 minus 5rs squared. So make sure, like in this case, the entire middle term got taken out. Don't forget to put back the 1 in there. All right, so this next one's gonna look a little bit different. So 26, we've got 5 times a plus 3, and that's all in parentheses cubed, and then minus 2 parentheses a plus 3, and then plus parentheses a plus 3 squared. So I'm still taking out the greatest common factor. So this one looks a little different, but the process is still the same. So what would I be taking out of this one? What do we see in every single one of them? Yep, a plus 3. So I'm taking that out as a group. So it'll be like this. A plus 3. And we need to keep it in the parentheses because when it's getting multiplied, we want to make sure it's multiplying everything, not just like the 3 through it. And then I like to do a bracket just to, I don't know, I just think it looks nicer. So then 5 times a plus 3 squared minus 2, because that a plus 3 goes away, and then plus, and again, in parentheses, I'm going to leave it just to make sure there's no confusion about what's happening. So it's the same thing, it just, looks a little different than we're used to. All right, so that was to take out the greatest common factor, and so we're going to kind of keep that mindset going into factor by grouping, because when we do factor by grouping, we're taking the greatest common factor out of each like pair of things. So 34, 20z squared minus 8x plus 5pz squared minus 2px. So factor by grouping, we group each section of them. So out of the first two, what's the biggest thing that can come out? 4. So that leaves me with 5z squared minus 2x. Focus this back in. It's getting a little blurry. A little better. All right, and then out of the next grouping, what can I take out?
1e.
Yep. So I can take out a p, and that leaves me with 5z squared minus 2x. And remember, when we do factor by grouping, we want to make sure that the two things that we're left with in parentheses match. If they don't, then we haven't taken the right thing out. Okay. So then our final answer would be 4 plus p times 5z squared minus 2x. All right, so now they kind of just throw us in to factoring. And so it's to factor each trinomial if possible. So some of them will not be possible. They would have to be like solved by a different method if we were going to do that. But all we want to know is factoring. So come on, here we go. 40, you got 9x squared plus 4x minus 2. So when I have just a 1 in front, it's pretty easy. I usually just figure out what the two numbers I need are, and then I just go ahead and write my two factors. But when it's got a number in front, we do the arch method. So we multiply the number in front times the last number. So I need factors of negative 18 that add up to give me positive 4. So anybody know factors right off the top of their head that would work?
3 and 6.
Okay, do 3 and 6 add up to 4?
Oh, for 4. Oh, my bad.
Okay. So the other thing we can do is, if you're like, I'm not seeing this right away, is we can break it down into a factor tree. So 2 and 9, and then 3 and 3. So we already tried 6 and 3, and that didn't work. 9 and 2 doesn't work. So, and like 18 and 1 doesn't work. So in this case, this one is going to be not possible. Starting off easy. And keep in mind, with one like this, it would have to be one of the factors is going to need to be positive and one is going to need to be negative, because when they multiply, they have to equal negative 18, and when they're added together, they have to be positive 4 in this case. So no matter how we looked at it, we weren't going to get a positive 4 out of the factors. So 42, 36x cubed plus 18x squared minus 4x. So we want it obviously to look like the problem above. So when there's an x in every term or something I can take out, I want to see if I can take out the greatest common factor. So this is going back to like the first problems that we did. So is there something I can take out of all of these pieces?
Yes.
Okay, what can I take out?
2x.
2x. So that's going to leave me with 18x squared plus 9x minus 2. So the big thing to remember here is this 2x has to go down with us the whole time. Because when we get our factors, if we were to FOIL it back, we have to get to this. So if we don't have this, we will never get back here. So, and assuming this is factorable, hopefully this one is. So we're doing the factors of 18 and negative 2. So a lot of times I just go ahead and write this because realistically, usually it's not whatever that multiplied together is. Like usually it's not going to end up being like negative 36, and 1, but sometimes it is. So, I'm going to break this down into 9 and 2, and then 3 and 3. So looking at that, okay, keep in mind one number is going to need to be negative and one is going to need to be positive, because when we multiply it has to be negative. When we add them together, it has to be positive 9. So any idea what the factors of this would be? Or like what two numbers can be added together to give me 9? Some combination of 2, 2, 3, and 3.
6 and 3, right?
Well, that would only be 18.
Wait a minute, wait.
It's got to be
So
36.
What numbers are we using? I forgot.
So this one, hold on, let me do a different color so you can see it better. This one, this one, this one, and this one. So we have to use all of them. And one number needs to be positive and one needs to be negative. So you can test stuff like,
18 and negative 2. Wait,
So 18 and negative 2 would only give me 16. I need 9. So you can try like
okay, I understand what we're doing.
6 and 6. You could try 9 and 4. You could try 12 and 3. 12 and 3. Okay, so 12 and 3 are going to be the two numbers. I need this to be positive, so that means that 3 is going to be negative. Okay? Because 12 times 3 is 36. Okay, so that takes care of this arching part. Then added together, that gives me positive 9, which takes care of this part. Okay, so the 2x is going all the way down with us, so I'm just going to draw the arrow and just bring it down to the bottom here, just so that I don't have to worry about it. So now I'm replacing this middle term with 12x and negative 3x. I'm going to put the negative 3 with the 18 just because it's going to make the math a little easier. But so 18x squared minus 3x plus 12x minus 2. So all I've done is basically rewrite the middle term as something else. Now I can factor by grouping. So what do I take out of this first group?
3x.
So 3x leaves me with 6x minus 1. And what do I take out of the second one? So that leaves me with 6x minus 1. So we're looking for the stuff in parentheses to match, and it does. So now down here at my 2x, I have that times 3x plus 2. So that's everything outside the parentheses. And then, technically there's a little plus sign there, times the 6x minus 1. that gets written one time. And so there's never a reason to get factoring wrong because you can always FOIL to check it, and then after you FOIL this, you can multiply the 2x, and that will get you back to the original. Now, if you learned a different method of factoring, last year Ethan had learned this like slide method from the school that he came from, and like it made sense. It's like an easier way to factor. To me it was harder because I'd never done it that way before. But if you're like, I know a different method, that's fine as long as you get to the same answer. I only had his method down for a little while and I don't even remember how to do it now. But anyways. Let's see, another one. 46. 12s squared plus 11st minus 5t squared. So this one, we're doing the same process. I just now have two different variables I'm working with. So basically when I get my middle term, they're just both going to have an s and a t on them. So the only thing I need to be worried about when I do my arch method and do the factor tree, gracious, something in my throat, is the 12 times negative 5. So I need factors of 12 and negative 5. So basically of negative 60. That give me positive 11. Any idea what those factors might be? Yep, 4 and 15 will work. So, again, I need this to be positive. So that means that my bigger number needs to be positive, so the 4 is going to be negative. So, if I can get the right color going on here. I'm going to do, and again, it doesn't matter which number you pair with which one. I just like to try to pair up numbers that, I don't know, look nice together. So I'm going to do the 12 and 4 and then the 15 and 5 together. So 12s squared minus 4st, okay, because that's because there's an s and a t on both of these. So to replace the middle term, it's got to be st, plus 15st minus 5t squared. So factor by grouping, what do I take out of the first group? 4s. And that leaves me with 3s minus t. What do I take out of the second group? No, 5t. Yep. So that leaves me with 3s minus t. So again, I say this over and over again, but usually when there's a mistake, it comes right here. These have to match, otherwise something's wrong. So 4s plus 5t times 3s minus t. Also, people usually end up asking me because a lot of people, their s's and 5s look pretty similar. So if that's like super confusing, as long as you change it throughout the whole problem, I don't mind if you change it to a different variable. Just indicate to me, like if you wanted to change it to x, up here show me that you're changing it to x, basically. Because unlike when we get to the trig stuff, it'll be the same thing. Like, people are like, can I rewrite this? I don't care if you rewrite the variable as long as you tell me what you're rewriting it as, and it's the same throughout the whole problem. All right, any questions about those? So the next one I'm going to show you, you probably haven't seen this before, still factoring, but it's just a different, not different method, but kind of a different way we go about doing it. So 58, I've got 2p plus q squared minus 10 times 2p plus q plus 25. So this problem looks different because now instead of x's being squared, or other variables, just that being squared and then it having like the x term or whatever, I now have this stuff in parentheses. It still looks to be a quadratic problem, right? Kind of like the problems that we had. Do you see that it kind of looks like that? A little bit? Okay. So I'm going to do, in this case, because they're using variables other than x, I'm going to just use an x for it. But usually we call it u substitution. But I'm going to say let x equal 2p plus q. So now anywhere that I see a 2p plus q, I'm going to rewrite it as an x. So I'm going to have x squared minus 10x plus 25. And maybe you're thinking, why am I allowed to do that? Because when I get to the end of the problem and I have factored it, any place there's an x, I'm going to replace it with that 2p plus q. So now, ignoring everything else that I've written so far, how would you factor this x squared minus 10x plus 25? What factors of 25 give you negative 10? Negative 5 and negative 5 multiplied together gives you a positive 25, added together gives you negative 10. So I personally don't go through and rewrite the middle step as minus 5x, and then factor by grouping. I just go straight to this. Okay, now, in this case, it's the same number, so you can actually write it like this. Either way is fine. They are the same thing. But I'm not done because remember, x is actually 2p plus q, and so I need to replace that down here. So this is going to be in parentheses, another parentheses, 2p plus q, close parentheses, minus 5, and then that whole thing squared. So don't stress about those too much. I might give you one of them to try, possibly. But I more so just wanted you to see it because should you continue on in math beyond this class or into like college, like calculus and stuff, you will need to have at least seen this before. But if you're like super confused, don't stress out about it. Like last year, I showed it to Algebra 2, I think it was, and we did something the other day in pre-cal, and they were like, oh, like, it didn't make sense then, but it does now. So if you're, like, super confused, it'll probably make sense in, like, about a year. That's what usually happens. I don't think it made sense to me till college, so. All right, so now we're on to the special type of factoring, factor each polynomial, and So our special types are what? What are two special types of factoring that we know about? They have fancy names.
Commutative? Okay.
Should have been under the title of factoring binomials.
Was this R3?
R4. Which I'm gathering, since you didn't have Google Classroom on your phone, you probably didn't do.
No.
It's okay. You can do them later.
Difference of squares.
Difference of squares is one of them.
Difference of cubes.
Um,
Some
yes, that is one. We're not quite there yet, but we will do that. We will do that, but not quite there yet. There's another type. Oh, the other type is above. It's under the methods part. I didn't realize they were under two different headings.
perfect square trinomial.
Yep, perfect square trinomial and difference of squares are the ones that we're about to use. So 60 is 16q squared minus 25. So which of those special types would this one be?
Difference of squares.
Difference of squares. So the way to think about this, if you're like not super familiar with it, is to basically rewrite this as whatever it is that's being squared, and it's got to be the whole piece. I'm really bad at drawing Q's. It's got to be the whole piece. So q squared was already clear, but 16, I needed to rewrite that. So 4q is my like a term from, make sure I use those letters. Nope, I used x and y. So 4q is my x term out of the notes, okay? Then minus, what squared is 25? 5, so that's 5 squared. So now we just write down 4q plus 5 times 4q minus 5. And all the difference of squares does is it basically gets rid of our middle term, and so that's why we can just go straight to this step. Are there really not perfect square trinomial ones in here? Maybe we're not doing perfect square trinomial. I don't even see one at the moment. All right, 66. In parentheses, I've got p minus 2q, and the whole thing squared, minus 100. So looking at this, maybe your mind is thinking, oh my goodness, she's about to make us do substitution again. I'm not. We don't need to. Because with a difference of squares, I just need to know what that term was that's being squared, and it's already written that way, so I don't have to do anything to it. And then what squared is 100.
I don't know.
10. 10 squared. So now when I go to factor it, it's just this first term plus this, and then times this minus this. So all this becomes is p minus 2q, and keep that in parentheses so it doesn't get confusing, plus 10 times p minus 2q minus 10. So no matter what it gives you, whatever term is being squared, we just take down whatever that term is, and that's where we put in our difference of squares formula, if you will. Apparently they must really not want us to do a perfect square trinomial because I really don't see one at the moment. Huh? All right, well, we're going to do a difference of cubes then. Okay, so just because this one is a less common one, a difference of cubes is if you have something like x cubed minus y cubed, so it looks pretty similar to difference of cubes, to difference of squares. This factors into, it's copied down exactly, x minus y, okay, minus, like, not having the cubes on them. So we copy down the terms themselves exactly. So if this had been a plus, it would have been a plus, but this is x minus y. And then in parentheses, x squared plus xy plus y squared. And if it had been x cubed plus y cubed, this was x plus y. Then we'd have x squared minus xy plus y squared. So we have, in this first one, it's the same sign every time. So same as whatever you started with. Then the next one is the opposite sign. So we started with negative here. This one's positive. Started positive here. This one's negative. And the last term is always going to be positive. Okay? So something, I don't know if, well, some of y'all may remember him. There's a guy in the class that graduated with like Garrett Hughes that his name was Logan. I don't remember his last name right now, but anyways. But he taught me this mnemonic or whatever to remember it because I'd never heard it before and it helped everyone in the class, so I like to share it. So it was in your notes, but it's SOAP. Okay, so if you had it, so it's same sign, opposite sign, always positive, is what that means. So just don't forget SOAP when you're doing a sum or difference of cubes. But it has made my life so much easier because I used to forget the formula for sum and difference of cubes all the time. Like in high school, I would like literally be like cramming before a test trying to remember what the formula was. And it's not something that should be that difficult, and it's probably been said before, but it was never like, oh, remember SOAP. So anyways, that's helped a lot of people since he shared that with me. I like to share it. So some examples of this. Let's do a difference of cubes first. So 74, we got 27 minus r cubed. So I'm going to, first of all, kind of like I did with difference of squares, I'm going to rewrite this in terms of both things being cubed just so it makes it a little bit easier to see. So what cubed is 27? Yep, so it's 3. So 3 cubed minus r cubed. So now it looks just like this first one up here in green. So I am going to copy down exactly with the sign, so same sign, so 3 minus r. Then the other parentheses. If you want to write it as 3 squared and then rewrite it as you go, that's fine. I usually, when it's a number, I usually just go ahead and square the number. So 3 squared is 9, so I'm going to go ahead and put 9 here. Opposite sign, so it's going to be plus, and then it's these terms multiplied together, so 3 times r is just going to be 3r. And lastly, always positive, in this case is going to be r squared. And then you're done. Let me see if I can get a sum of cubes. Alright, I'm just going to do 80, but I'm going to modify it so it's, not really going to be problem 80 at all. That's fine. I'm going to do, it's going to be 8x cubed plus 27. So I'm going to rewrite this again. So what cubed is 8? 2. So this is going to be 2x. And then I like to write it this way so that when I'm going through and doing my terms, it already looks like it did up above. And then plus, we already had said 3 cubed is 27, so it'll look like that. So first step, copy it down, basically the same, so same sign, so it'll be 2x plus 3 in the first parentheses. Then it's the first term squared, so this is going to be 2x squared, so that's going to give you 4x squared. Opposite sign, so it's going to be minus. We multiply this times this, so 2x times 3 is going to be 6x. And then always positive, and then it's this term squared, so it will be 3 squared is 9. Any questions about any of those or anything we've done? All right, so a couple of the problems, some of the sections kind of tell you like specific instructions, but there's a couple of problems at the end that I'm going to give you that it says to factor by any method, so you can just like pick your favorite. So that could just be factor by grouping, it could be arch method, it could be like the sum or difference of cubes. It just depends on the problem. So, but you get to pick your method on that if it doesn't specify. So your problems are 17, 25, 31, 35, 49, 59, 75, 99, and 103. And if you don't finish today, because there's not a ton of time left, there's only about 10 minutes left, you can have some of the time tomorrow, and then we'll do a little bit of review for the quiz on Wednesday. And then after the quiz on Wednesday, you'll have time to do the 1.5 notes so that we can do that on Thursday. So.